Okay, let's back to the neck entropy. Okay, we use the neck entropy to measure the non-Gaussian larity. Okay, because if we follow the Gaussian distribution, then this is nothing but a constant term. And we use only one non-projective function so that our objective now becomes okay, then we try to find the projection so that this non-projective function will be maximum, okay? But again, the entropy is based on the probability. Now, we have no information at all, okay? We know nothing about the distribution, then there's no way you can estimate the probability. But so here, the original author tried out three here, okay? Cards will be here later on. We will introduce an ICA tool called Fast ICA, available on scikit-learn, okay? So that you have three, okay, choices. You can select G1, G2, or G3. As you see here, G3 is nothing but the kurtosis. See, kurtosis, okay? If we have no idea, I would suggest you just go for G2 first. Just go for the G2 first, okay? And here is the shape or distribution. This is for G1, okay, very sharp. As I just mentioned, it is very sensitive to noise, outlier, okay? Then this is G2, okay? Because you put a minus sign here, so you will see, okay, the shape, okay, becomes negative, and this is the G2, okay, G1. You can try out G1 and G2. For G1, there's a parameter. You can use the default value if you have no idea at all. Okay, you can use the default value, or you can change the value. As they say here, it suggests that this value should be between 1 and 2. Okay, just you can try out what would happen. Okay, but you have no idea at all. Just go for G2. Just go for the G2. That will be fine. Okay, just try G2. But anyway, for assignment number 1, you can try out G1, G2, or G3 and see what will happen to gain some experience. That's the purpose of the assignment. Okay, I would like you to try out something, and you can learn it and get the. About the assignment, one more time, as I mentioned, I don't need a standard answer, and there's no standard answer. Okay. The grade is based on your effort or your analysis. What is your finding, and what can you learn from the assignment? That's all I expected. Okay, I don't need a standard answer. Okay, and actually there's no standard answer for that. And you can ask ChatGPT or Gemini. That'd be fine with me. Okay, you're encouraged to use it. Okay. Well, actually, I asked assignment number 1 by using Gemini. And he agreed with me the assignment is good for you to practice the knowledge on PCA and ICA. But it further suggests I should add some theoretical analysis. No, I won't ask you anything about it. Okay, but just get some practical experience, okay, from the assignment. That's all I ask, okay? So anyway, G1, G2, and G3, okay? And all the remaining, you don't have to worry about it because it has taken care of the optimization. That's the first derivative. And then, okay, that's the first derivative. And anyway, I will skip some of the details, okay? anyway, that's the gradient. Okay, I won't talk too much about the optimization, but anyway, that's if you go for the gradient of the ketosis, that's the way we estimate the gradient. Okay, and then we can go for the gradient descent. Okay, then we can go for the gradient descent. That's it. But the traditional way, very important. You need to set up the learning rate, just like the deep learning. Okay, the learning rate is very important. If the learning rate is too, this is a so-called isogram. You know what I'm saying? 等高线，就爬登山那个不是有等高线 ？It means what? All the data on the curve here will show you some constant output. Okay, constant output. And then we try to find find the peak. Okay, that's it. Anyway, when you're starting from here, then it might suggest you go for here, and based on this, then you will look for. But if the state size is very small, you know you will take a lot of steps, right? But if the state size is too large, you might overshoot the true optimal solution. Okay, so it's very important. So usually you have if you can change the learning rate, usually at the very beginning, we use a very large step size to move faster. And later on, you will reduce the step size to a very small, okay? And hopefully, you can try to find the true optimal solution in the nearby, okay? So learning rate is very important, but for ICA, good for you. I mean, if you have to write your own optimization algorithm, the learning rate is not required. Actually, you use a so-called fixed point, called fixed point optimization. Okay, you use a so-called fixed point optimization. The reason for that, if you look for the because this value, this is the projection, can always normalize. Okay, so that you will be a unit vector. 因为它这个的，因为我们只关心投影方向嘛，那个值大小一定都不重要。所以弄完以后呢 I mean, this learning rate can be normalized. We don't need to care about how to set up the learning rate, but it just apply for this because we care only about the position direction, and this direction can always normalize to make it a unit vector. Okay, I will skip the details. I won't say anything about it more. Okay, so that's the idea. So you don't. But again, if you cannot find a good converge of the optimization, you are encouraged to try out several different initial position, okay? Initial position, and see, because it might get stuck here. For example, you might get stuck here, but actually if you go, okay, you climb up the mountain from the starting point here, it may eventually to hit the top of the hill. Okay, so it could be better. You can try out several. You don't care much about the time. Okay, for the ICA, no, you are encouraged to try out several different possible way. Okay, to make sure you can truly get to the top of the mountain or hit the ultimate solution. Okay, so anyway, if you want, you can go through the details, okay, for that, okay. Here it show you a lot of, I won't, because that's what I'm saying here. Let me, So far, for assignment number 1, the only thing you need to remember is you have a G1, G2, and G3 to select. Okay, that's the three. That's the three non-quadratic function that you can use. Okay, and for G1, there's A1. That's between 1 and 2. Okay, you can try out for your assignment number 1. Okay, and it's very efficient. Okay, it's very efficient. If I have the time, I will go back to finish all the remaining, if you're interesting about the optimization part and why it's called fixed, okay? Because you need a lot of nonlinear programming background to understand that, okay? That's what I'm saying, the fixed point algorithm, okay? When you run the science kit, then for ICA, it is based on this algorithm. Okay, so basically it's quite efficient. Okay, you can converge it just in 10 or less than 10 iterations to reach the goal. Okay, so what I'm trying to say, actually you can apply that for online real-time application. Okay, for that. Okay. One more thing I'm not quite sure the science kit run provide this function or not. Okay, one is called deflationary, okay, orthogonalization, which means for this case here, we have M projection. We have M projection to estimate. So if select deflationary, it means you will estimate the very first projection direction and then the second and so on and so forth, sequential. 也就是它会猜第一个投影方向，猜完以后呢，再猜第二个，再猜第三个，再猜第四个，这样的策略呢叫做 deflationary。我不确定那个 science kit 有没有等一下也许你可以问一下 Carlos。另外一个呢叫做 symmetric， the other alternative is called symmetric orthogonalization, which means what? Oh, it's not here. It will do the parallel estimation for a matrix simultaneously. Let me say it again. For deflationary, it do the estimation of the projection direction sequential, W1 and then W2 and W3. But if you go for the symmetric orthogonalization, then you will estimate W1, W2, and Wm simultaneously. Then sometimes you will get different results, okay? And see which one will better to fit your need. So you can go for the sequential or go for the parallel, okay? 知道我意思吧？好，这个是猜完第一个投影方向才会有第二个哦，第二个完才会有第三个哦。那另外一个呢，假如你用的是 symmetry 的话，它是把所有的投影方向一次呢一起猜，听得懂就一起猜，好，一起去猜。那各有优缺点了，你去看啊，它所需要的时间。假如都没有的话，你问我个人意见，可能symmetric 可能会更I mean it just personal okay opinion. It may not be true all the time, but it's okay. Then you just go try symmetric first. Okay, go find symmetric first because you can do the estimate all the projection direction simultaneously. Okay, but for this one, you just calculate the very first one, and then the second one must be something to do with the very first position, and so on and so forth. Maybe even you have more restriction for that. Okay, so anyway, basically you have two choices for that. Okay. Because I promised Carlos, I will stop it. Okay, 45. Okay, but since I have a time, let me show you again, because for when I talk about the PCA, I show how to use it for face recognition, right? Right? Okay, ICA, there's another application for that, okay? So I skip a lot of mathematical details, okay? I leave it to you if you are interested in that. But anyway, let me show you the application for that. Now, how to use the ICA for classification, okay? Or how to find the basis. Remember, when we talked about the PCA, I mean, you can use PCA, the eigenvector, as the basis, right? 基底嘛, it's the same here, okay? Now, suppose U equal to W times X. So W here is the dimension matrix. You can use fast ICA to do the estimation, okay? You can simply just use the fast ICA. So U means the estimate. Well, we expect this should be just like the original sources, okay? Then W times X, okay? This is the dimension matrix, okay? Now, it is estimate. This is the input, what you observe. Okay, what you observe. This is the input. That you collect the signal or the image or anything. And this is given by the fast ICA. Okay? It will return this matrix to you. And then this will be the estimate, the sources. Okay? That's it. Okay? That depends on the size. If this is M by N, and this must be something by M, okay? And that's it. This is the dimension matrix, and this is the estimate sources. Okay, this called U. Okay, everyone follow me? You don't have to worry about how to solve for the dimension matrix just by using the scientific, okay, phase ICA. It will return this dimension matrix to you. Now we can use architecture 1. Or we have architecture 2. Maybe we just talk about the architecture 1. It's quite. First, this is how we arrange the X here. Okay. Suppose for this case here, we have the time signal 1, time signal 2, and suppose we have a 3 times X1. X2 and X3, okay? X3. For your assignment number 1 is a SPC signal. The length is 60, okay? The observation, you have a 60 time series data point, okay? Suppose we have a from sample 1, sample 2, sample 3. Now, if we, actually the other way around is you can put X1 by column. That's another story, okay? Now let's take a look here. It means what? The independence is measured, okay, for each phase time step T here. It means what? When you know something about the output of X1, it cannot help you to estimate the output at the same time for X2 and X3. They are independent, okay? They are independent. But if you put it by column, it means what? For the same time series, when you observe something at time t, it won't help you to estimate the output sometime later for the same time series signal. But this independency says mean independent between samples. This is for the same sample, the independency is measured at different time steps. Okay, so let's go back. So first, you need to know how to arrange your input data set. Okay, otherwise, you might have the input like this and get the wrong interpretation. Okay, so first we go for this. Okay, and then you can use fast ICA to find the diminishing matrix, and you get the U. That's it. Okay, and then we use U as the basis. Okay, U1, U2 is something from this. Okay, because this the sources, we use the sources for U1, U2, U1, and then we use this as the basis, and the combination, the coefficient as the features. That's it. Okay. So U1 for this case here could be represent the eyebrow, the lips, the nose, the face, or anything. Okay. Anyway, once you have W, then you can have U. Then we use U, the vector, okay, as the basis, and then we can reconstruct any input time signal or for this, because its original application is for face recognition, just like eigenface. But anyway, we use the coefficient as the features, okay, for unstructured data, okay, for unstructured data. That's okay. So you use the role, see that? You use the role of the estimate, okay, source matrix. Of course, you don't need to use every single one as the basis. Kind of just like the PCA dimension reduction, but it's up to your application, so that you can determine the total number, okay, of features you are going to use to represent the unstructured data, such as the imagery of time series data. That's it. Okay, then can go for it. Okay, that's what I need you to do for your assignment for that. Okay. Anyway, and the coefficient, I just write it here. Okay, that's what you can then B. Okay, and then B is the representative features. Okay, as I mentioned here, this is the input X. Okay, then B here, U is something you estimate. And then you can find the inverse of W, then you can calculate the B. B is the coefficient here. See that? Okay, but so everything is based on the diminishing matrix, but you need some further calculation. Then you can get it done, okay, for IC. Okay, so I think I will stop here, and let me before as I just please download. Here's two parts, okay? One's autoencoder, the other is convolutional neural network. Okay, as I just mentioned, I decided to put this part forward. Okay, usually I would talk about the deep learning after the midterm. Okay, but I think it could be a better way to let you learn more about learn some deep learning. It'll be good for your assignment or even for your final term project. Okay. I was starting from the convolutional neural network. Okay. If I have time, as I promised you, I will talk about the transformers. Okay. Convolutional network is basically can be applied, used for classification and the regression. Okay. Very important tool. Okay. I was starting from here. And then later on, I will talk about the autoencoder. Because convolutional neural network is so-called supervised learning, which means you need to give the input and also the expected label, okay? But for the autoencoder, you don't need to label or notate anything, just because for autoencoder, just the input the same as the output. So autoencoder will be encoder and the decoder, okay? There's the autoencoder. And we have the input and the same input as the output, so that we don't need to worry about how to set up the good thing about it is we can do some, we can extract the feature, okay? We use it as the feature extractor. Especially for unstructured data, time series data. As mentioned, I will focus more on time series data this semester. So you can do the feature extraction automatically. Okay, that's one of the reasons why I want to talk about these two parts. Okay, and with the feature, then I will go back to talk about the traditional machine learning, okay, such as SVM or random forest or anything else, okay. And then after that, then I will go back to talk about more topic, okay, more advanced topic on deep learning, okay. That's my plan. So trying to download the convolutional neural network and autoencoder, okay, and bring it next week. But let me ask one question. Do I have to talk about convolutional neural network? If every one of you already know what CNN is and you can use it without any difficulty, so don't be shy. Let me know. Raise your hand if you want me to talk about CNN. Anyone? So I can skip it, right? Sure. Okay. You sure you want me to? Okay, because if you are quite familiar with CNN, I believe a lot of you have used it for your term project or assignment or other, but so if you have know something about it, let me, especially for some of you from Taipei Tech, it's okay. I just repeat it. I promise I'll finish it in a week. Then I will talk about the autoencoder. It's okay. 哎，你假如都不需要，我就不要讲了，因为你们都知道怎么应用，我就不讲哦，不要浪费我们浪费一节的时间哦。要不要讲？第一个要不要讲？要不要讲？哎，不要都没反应了，要不要讲？ I see some of you raise your hand, but only a few. But okay, I will summarize. CNN, it's okay. It's okay with you. Okay. But anyway, if you haven't know how to use, just refresh your memory because when we talk about the autoencoder, we still need some the idea about CNN. Okay, the autoencoder, and then we will focus on. We will focus on the feature extraction. Okay, feature extraction. Okay, because it's a very important topic, and the reason for that is then you will have your assignment number 2 and 3 continuous with assignment number 1, so that you can make the comparison and you can learn the experience, and then you can think of what should be your term project look like. Okay. That's my purpose. But for the time being, I will just, starting from next week, I will just take on the autoencoder and convolutional neural network and all others. Okay, I will wait until we finish the traditional machine learning. Okay, then I will go back. And as I mentioned, I will talk about more about even for the example and how to do the example and a lot of different application. Okay, so let's. As I just mentioned, I hope I have the time to talk about the time series for long-term time series focus based on UNet. But UNet still encoder-decoder architecture. Okay, I will talk about that. Okay, if I have the time. As most of the Taipei Tech students know, is my personal favorite model. Simple, effective, very efficient and very effective. But I hope because it just released up to 2 months ago. Okay, only 2 months ago. But it can make a long-term estimation. And it has compared even with the transformer and show you the better performance. So I hope I have the time for that. Okay, anyway, so I will finish the remaining part of ICA next week, and I will talk about the CM briefly. Okay, I simply assume just give all the required information you need to understand CM, and then I will focus on the autoencoder. Okay. I will talk about two. One is the convolutional autoencoder. The other one will be the variational autoencoder. But later on, I may talk about the diffusion autoencoder and also mask autoencoder. Okay, both use a lot, especially for large scale modeling, even for such as ChatGPT or the image generator. Okay, they all based on this. I mean, I have time, but anyway, that's something. Well, you learn this, that'll be good enough for you to do your project. Okay. So that's my plan. I thought Carl's would be. Yeah, he's here. Right. Good. Okay. Now I thought. And Carl's please just also finish the last part of the assignment. Okay, I didn't mention it today, but okay. So basically, no, Carl's come over. Okay, no, it's your turn. You can talk about the fast ICA. I already introduced G1, G2, and G3. Okay, so we can talk about how and how to apply it for the second part of their assignment. Okay, so that's it. Okay. Okay, no, I'll let you talk about it. Okay, if not, I think they will know how to do it. Okay, good. Okay. Anything about the programming, go ask Cal. Anything about the assignment, you can come to me. I prefer you talk to me, okay, face to face, instead of send me the email and ask me a lot of questions, because okay, you can ask me during the class break or come earlier, okay, before 1 o'clock. Okay, so that'll be fine with me. Okay, but anyway, about the programming, go ask Carlos. Okay, so that's for your assignment number 1. Okay, and don't forget to download CNN and autoencoder. Okay, for our next week's class. Okay, and see you then. Okay.
就其他嘛，就
为什么你不用训练？
我们是展览的话。
Okay, because last week we didn't have enough time to teach you how to install the required packages, I will teach you now. Now we have time. So I recommend you to install Anaconda. You can just download the installers, just double click. And you need to create an environment. You just go to environments, how far to main, just create, write any name, for example, data project. And select any Python that is above 3.7, 3.6. The computer should have 3.8, which is fine. And then create and wait, okay? That's how it's easy. Now how to install the packages. Let's say we are in, the one I use is this one. Okay, just click and you, there are several ways of installing packages here. However, I don't really like how the graphic interface of this, so I usually use the terminal. So you can click in the play button here, open terminal, and then we'll open a terminal with the environment. The three packages you need are scikit-learn first, NumPy because it's needed, and matplotlib. So how to install packages here? You can use pip install, and then write the name of the package, scikit-learn, matplotlib, and NumPy. NumPy, and then just click enter and wait. I already have it, so yeah, that's it. Just the internet, and that's it. That's the way to install. I think it's much easier than looking here, and usually the packages are more updated in the PIP repository than the conda. So that's how to install it. And I recommend you install the Jupyter here once you are in your environment here. I cannot make it bigger, sorry. You install the Jupyter notebook, okay? And that's it. You open it and this is what we got. Okay, so for this assignment we are going to use PCA and fast ICA from the scikit-learn, which to install it, remember is the full name, scikit-learn. But to call it is sklearn. Okay, for the decomposition modules, import PCA, fast ICA, and for the metrics we are going to use the confusion matrix, right? So you just call it confusion matrix. Import matplotlib to plot and NumPy just to load the assignments. Okay. How to load files? We use the load.txt, the name of the file. In the directory you open this notebook. The limiter comma because it's a CSV file, and skip row 0 because it doesn't have a header. So here I'm opening the two files, the data for the source separation and the data for the anomaly detection. That's why I call it here. I'm going to upload this to the portal so you can have it, no problem. So we open it and then it's I didn't run the first one, okay. So for the confused here. Remember, for the anomaly detection, we have 300 samples, right? 100 for each class, and 60 columns. For the signal separation, we have 3 signals. Therefore, we only have 2 sources. Okay, so let's take a look at the data again. How is for the source separation? We can see that nothing, right? Pure noise. This is how it should look like. Now, how to perform the source separation? We just call the PCA in this case. number of components 3, that's the only parameter you need to write. And we just call fit transform, which is what's going to do is two things. Fit first, which means calculate the eigenvalues, eigenvectors, then perform the matrix multiplication by and then it's going to use this data and transform it to the original sources. Okay, that's it. You can see here something like this, something like looks like noise, something like looks like it's increasing, and something like looks cyclic. Right? That's it. For the ICA, we need 3 arguments. It's called fast ICA, the number of components, of course. The function you are going to use as a negentropy approximation. We can use low-cost, exponential, and cube. And the number of iterations. Because remember, fast ICA is an iterative process, so we need to set it. How many? No idea. So you should write, for example, if I write 2, most likely it won't converge, right? Let's see that the warning here. Convergence warning. Fast ICA did not converge because there are not enough iterations, right? So let's put 100 and see, yeah, it's converged. And now we can see here the results. Remember that fast ICA is a stochastic process, so the weights are random. You won't ever get the same results. If you run it again, you will see different results each time because the weights are initialized random. Okay? So each time I run this, I will get different results. You cannot have the same results. Yeah. Remember that ICA does not know anything about the scale, so you shouldn't compare these values, 0.2 minus 0.2 with the PCA because they don't relate to each other. ICA does not know about permutation either, which means the order of the signals are different, right? So we can say this signal generates the source. No, there is no relation there. Okay? You don't know that, and you will never know that. Okay? So that's the reason why we have this randomness. In this case, this is increasing, but if I run it like 5 more times, or I don't know, it may be decreasing, right? See? Because it's a scale. It's -1, right? It's multiplied by -1. Questions so far for the source separation? It's easy to perform, but you need to understand what's going on here, why the results are different, why we give you upward shift and you got a downward shift, right? You need to know why. Okay. Now finally, how to get the mixing matrix from the ICA? You just use the attribute mixing, here, with the underscore, and then you get this mixing matrix, the approximation of the mixing matrix. This matrix is nothing more than the mapping from this source to this observed signals. Yeah, if you multiply this, these recovered sources by the mixing matrix, you will get the observed signals, right? As here. Okay, so let's go for the next part. Okay, so for this, you are going to use a 50 normal samples as training, right? That's the whole idea. So you can just use some slicing here to select the first 50. And now we will have 50 rows with 60 columns, right, for the anomaly detection file. Now you need to calculate the eigenvalues and eigenvectors. That's from the covariance matrix, because that's PCA, basically. So we calculate the covariance matrix by using NumPy, use cop, and then input the data. And then we can calculate the eigenvalues and eigenvectors by using, again, NumPy in algebra, eigen, covariance matrix. And then we will have 60 eigenvalues and and an eigenvector of 16 by 60. So it's sorry. So that's how we calculate the coordinate matrix, eigenvalues and eigenvectors. One thing you need to realize is that the eigenvectors are already sorted by eigenvalues. If we sort them, you see the indices of the sorting is 0, 1, 2, 3, 4. So they are already sorted in descending order. You don't need to sort them. This means you already sorted. And you don't need this code. I'm just showing you that it's already sorted. So see the 0, 1. This is just to get the indices of the sorted vector, and I use the real because it has some imaginary components. You can discard them if you look at the values are really close to 0, so you can discard them, and then just inverse them. That's it. Now finally, how to obtain the feature vector, because the feature vector is nothing more than the multiplication of the selected top eigenvectors by the observed signal, right? And you just do this. You can, for the matrix multiplication or vector multiplication dot product, you use the at symbol. Chain alias to make it easier. So just use the at symbol and that's it. Okay, so this is the part for the feature vector. And because I selected five, the number of vectors only 5, then I will have 50 because it's 50 samples and 5 because I selected only 5 and 5 can put here like 50. 15 by. Remember, this has to be less than 60, right? Because the number of features is 60, and then the idea is to dimension reduction, so we cannot have 60 here or 59, then we're not doing nothing. How many you should try? I think you should start with 10 and up to 40 maybe. But yeah, I think 50 is too many, and 10 maybe too little. So just try several numbers and see. Yeah, then you can do a lot of experiments with the number of these. Okay? And basically that's it.
That's it.
Yeah, you just need to calculate the distance from to perform anomaly detection. You take a look at the assignment. Basically, the first part, the signal separation is already done there, right? You just need to talk about why and how. And the second part, I just leave it until here, right? This is the feature vector, right? What you do after this is up to you. Because basically, you just compute the distance, right? But do it with the remaining signals. It's 150, right? Sorry, 250, which is 300. How you measure the distance? You can use L1 distance or Euclidean distance or Mahalanobis distance, any. Okay, finally, so to mention the confusion matrix. How to use the confusion matrix? You just need labels, basically. You have to assign each vector to a class. In this case, it's anomaly detection, so either it's positive or it's negative, right? So 1 or 0. And you need to know the ground truth labels. So you just call confusion matrix. The first argument is the ground truth labels, what you know. And the second argument is the predicted, yes. And then you just print it, and it's something like this. And then you have the confusion matrix. Questions? No? Okay, then that's it.